Hi everyone. First of all, thank you for coming. I know it's been a long day of session, and I'm the only one who's standing between you and the beers that comes after. So I really appreciate it. And I'm going to talk about Spring Gateway and why is it such a perfect solution. But I'll start by introducing myself. There you go. So my name is Dan Erez. I work as lead architect in Zim, which is a shipping company, and shipping as in real ships and containers as in real metal containers. And I've been around for quite some time. Grew up with Java and Spring. I still remember the XML configuration of Spring. Lately I've been doing cloud architecture and enterprise architecture, still dealing with Spring, and also speak in conferences and write some stuff, so feel free to connect. This is the high-level agenda, but first I want to tell you that I've submitted this session about Spring Cloud Gateway because I remember when at the early days of microservices, when they're just starting to catch on, and Netflix contributed their open source libraries to run and manage microservices. Spring Cloud Gateway was a great solution. It was very common. It was before Kubernetes deployments took place. And nowadays, you don't hear that much about Spring Cloud Gateway, and I think it's a shame. So basically, I'm here to change that and to bring you back home. So my goal in this session is to convince you that not only that Spring Cloud Gateway is a good option for a gateway, sometimes it's the best option, depends on your case, in your use case, of course, and I'll review that. But let's start at the beginning, bring everyone to the same page, and talking a little bit about API gateways. A few years ago, and sometimes, I guess, some of you still working in companies where monoliths are there, and maybe you're trying to break the monoliths and move it into microservices. But that was the standard at the time, one big monolith that you compile and run as a whole. And then microservices came in. Now I think it's the main paradigm. People even start thinking, when they're thinking about a new application, they're already thinking in microservices, in modules, which is great. But it's a double-edged sword. Nothing is perfect. You always have the downside for everything. And one of the downsides of microservices is the complexity. If you have too many, you have to manage them, and you get this tangled web on the right side. And one of the ways to put some order to it is using a gateway. One in front all services, hiding the complexity, the number of instances, the specific addresses of the services behind. This is like the basic functionality of gateway, which is routing and finding the services, but it can do much more. Not sure how many of you are using an API gateway or using all of these functionalities, but all of these are important for modern applications, right? So if you get some of all of these things out of the box, it means that it saved you the work of doing it yourself. It can be adding information or doing rate limiting, which is important, or whatever is written here. And some other stuff as well, but these are the main functionalities of a good API gateway. I briefly talk about a few of these. Main functionality, of course, is routing, right? Hiding the exact location and instances of the services behind, doing some load balancing, maybe. Interacting with some service discovery, like Eureka, to find the actual instances, and doing some filtering, right? It can be done by almost anything. Common values are the path. Slash orders go to this service, and slash, invoices goes to another service. You can filter by header or route by header, or actually looking at the data. These are all like valid business cases. And I think you should know your options, right? And we'll review them specifically on Spring Cloud Gateway in a minute. Of course, you don't have to route everything inside. You can route some of the requests to an outside server, making your life more hybrid, right? You can run some of the stuff on-prem, some of the stuff in the cloud, maybe direct to completely third-party services. You can do whatever you want with this routing capability. Of course, this is an important part of handling web requests. You have to authenticate, and a good API gateway will do that for you, right? Maybe direct to a login page, get a token from some identity management server. If you're working in a Windows environment, talking Kerberos is a good thing. And pass, usually you pass a token inside, JWT. Who's using opaque tokens? Oh, one or two in the three. So, but most of you are not, meaning that you reveal the token information. So consider using them instead. Basically, they are some form of encrypted string, which you use as a key to get the actual information that's out there in the JWT. Just a note. And caching, right? If you have lots of users, and if you're lucky and have lots of users, then caching might be a good idea. Can reduce lagging and improve performance considerably. And we'll talk about that more later. Controlling the flow is also another functionality. Sometimes you have too many requests. Sometimes you want to limit the users by IP or by user or by whatever you want, so you won't get stuck. And you can use circuit breakers easily with an API gateway, meaning that if your service that you call to is down, you can set an alternative. And we'll talk about that too with Spring. One last option is controlling business flows. It doesn't have to be technical flows. It can be business. You can aggregate. You can chain requests. You can do whatever you want with smaller building blocks, making development faster and safer, right? You don't have to rewrite code. And if you work in big companies or companies that have been around for a while, you know that there are duplications all over the company. People are writing the same stuff over again in different teams. So if you write small building blocks and put them together in some form, again, aggregations or chaining, this can save you this duplication. You can add in some API catalogs so everyone else in the company will know what are the available services, but that's a matter for a different talk. Spring is not your only option. I want to be fair. Today there are like many available options. These are only a few. If we'll take Kong, for example, this is how it works. In a request, there are services that point to the actual provider of the service, and you can define one or more routes that leads to it. It has some more capabilities, of course, but this is the basic. I can show you an example. This is the UI of Kong. It shows you the services. One of the services goes to one website, others going to Amazon, to some lambdas. And you can see that there are a few routes. They have like oh, sorry. Should have told me. Yeah, I'll get out of presentation mode. Sorry. So this is the UI. This says now here you can see the services, change configuration. and they have the APIs to use. So you can write your own UI or connect it to some other scripts along the way. And you can actually call some services and get responses. A nice API gateway, not as good as Spring Cloud Gateway, but nice as well. Of course, you can use some other gateways in the cloud. And also Kubernetes has actually, it's a new object in Kubernetes, the API gateway that they have. They used to have Ingress and other stuff that used to do the routing. Now they have a full API gateway. Again, nice to know, but not as feature-rich as Spring. Let's take a look at AWS Gateway. Yeah, this time I remember to take it off. Let's create. Should be pretty simple. Let's add an integration to some service. Let's call it and there we have this API gateway. I expect the root not to bring me anywhere, but if I'll add the specific path, I get a response. Pretty fast, pretty simple, but I think that's the problem there. It's maybe too simple. Let me get to presentation mode once again. Now, the star of the evening is Spring Cloud Gateway. As you know, it had a first version a while back that was named Zul. Anyone knows why Zul? Whoa. Tell me. Yeah. This is Zul. It looks like a nice fella. And nowadays they've got a better version built with Webflux. It's reactive. If you want, you don't have to. It can do these things and more. And I think the main feature, which I'll show later, is the fact that it's customizable, right? But it has many advantages. It's part of Spring, first of all, right? It talks to Eureka. You write it and handle it as a Spring application. So it's familiar. It's reactive, meaning that it has a lot of throughput and high concurrency. You can move it around easily as it is a Spring application, take parameters according to the environment. And one of the best features that you can write it, right? You don't have to wait for a DevOps person to configure API gateway and add a route to your application. You can do it on your own, locally, on every environment, which is a big plus. But just to be fair, some cons. If you're new to Spring, and I guess you're not if you're here, then you have to learn it. And I didn't find any good GUI for it. So it's a minus for that. This is like the high-level sketch of what's happening for a request. When a request comes in, it goes through some global filters that can operate before or after the request. And then according to some predicates, the right handlers are being activated and the accompanying filters, meaning that you can apply some filters according to the path, the header, and some other options I'll see, and to pinpoint the request that you want to handle in a very fine granularity, and basically do whatever you want with it, right? And see what it is, what are the options. For configuration, you have two options. One of them is the familiar declarative configuration, looks like that. Basically, there are two services that we're writing to, and the order and the users, and we do it according to the path, right? It's a common use case. Or you can do the code-based configuration. This is the same configuration in code. I like it better, but you know, it's a personal preference. And these are only some of them, but there are many predicates to catch requests and route them. In Spring Cloud, you can do it according to cookies, based on the date, the path, the header, the request body, query parameters, whatever you need. And I'm not familiar with any other API gateway which is so rich in options. And of course, you can extend it on your own. The global filters are applied to every request. You can have a few, and you can order them. And there are many use cases in which you want to handle all requests. For example, logging each request, right? Or adding some context, the user, or whatever context you want to add to every request. It's easy to do so with a filter. And of course, the dynamic nature of Spring Cloud Gateway allows you, for example, to go to some cache somewhere or to the database and have it dynamic again, as opposed to other API gateways which that they can be dynamic, but you have to write, for example, plugins to do that. Here you write Java code or reuse Java code you already have and get that in an easy way. So let's take a look and see. I have some examples. Don't worry, I'll go easy on you and start from the beginning. Hope you can see. No, you can't see. Right. I hope it's large enough. Is it? Yes. Okay. So we'll start with the simplest example. Maybe I'll take it a little bit larger. Basically, that's a route, right? We're going by the path, and if the path is /get, we add a request header and go to this address. It can be an internal service. In this case, it's an external service that gives you some information. So let's start it and see how it goes. Assuming we started, we get a response from HTTP bin, and this is the request header that we've added. Great. Now let's take it a little bit more complicated. Circuit breakers, right? First of all, we'll do it without, and then we'll add one. Now I'm sending HTTP a request to delay the response. So I expect to go over Spring Cloud Gateway's timeout and get a timeout error. I do. But we can do better. We can set a fallback and basically return whatever we want, right? And what do we return? Well, it's up to you. You can return, for example, the last good response from some cache. You can return a default response, right? If I'm asking for a configuration of a user, I can send the default configuration instead. I can send a nice error message for the client application to behave nicely and maybe retry later. whatever you want. And if you wonder whether you need to create such a circuit breaker for every service, then the answer is, again, up to you. Depends on you and how nice you want to be with your users, right? You can do one generic, I'm unavailable, try again in a few seconds response and send an email or send an SMS to someone alerting that the circuit breaker was activated, of course, log it, etc. Or you can do specific answers for specific services depending on the criticality of those services. But you can see it's very simple. I'm only routing it to a different path, returning some stuff. Let's see it in action. Now, since I've applied the circuit breaker, I don't expect to get the timeout, right? Okay, what did I get? I get the fallback option, okay? Let's do another one. Caching. Right, like I said, caching can give you a lot of advantage performance-wise and get the load off the thing. The one thing that usually is the single point of failure, your database. So it's useful. And as you can see, it only takes one line to apply a cache here. I'm using caffeine in the background. So let's start that. And if I go directly to HTTP bin, hopefully you can see that. And when I refresh, you can see the Amazon trace idea. And it will change in every refresh. Right? Things that I don't expect to get when I applied the cache here. So not sure if you can see it. Not a good idea. Sorry. I hope you can see it, but believe me, it stays the same due to the cache. So far, so good. Let's take it another notch up and look at changing the body of the request. If you wonder why you should change the body of the request, sometimes you want to fix stuff. In this case, I take the message and uppercase it, and you can see it's done with one line of code. Sometimes you want to add context, like we said. You want to check the fields. You want to do whatever you want to do for any request, maybe even change the format. If you get XML from old system, you might want to change it into JSON and send it inside, or do any other formatting to match the requests, the services upstream. And you can see how easy it is with Spring Cloud Gateway. Again, harder to do with other API gateways. So let's see how it goes. And you can see it actually caught the request and replaced the body. Excellent. It doesn't have to be only the request. Let's do stuff to the response. In this case, I'm going to some inner service that returns some confidential data that it shouldn't. It returns, let's say, credit card information. But you can use it for any response. Remember, the response is being sent outside, and you could do whatever you want with it. Again, enrich a response, check for stuff that you're not supposed to send outside, or reformat. Again, so you can have one API that sends, let's say, again, JSON, and you can reformat it here for any client according to the path or the origin, for example. So you keep your service, your business service clean, and change whatever you want with it. Sorry, this time I'll start it in debug mode. Changes. So if we look at the information that I'm trying to return, you see there's the credit information here. We don't want that, so we mask it. And we actually got it, getting it masked. A nice way to apply to any request. And the last example is about size limiting. Right, another way of rate control, so to speak. And it's useful. First of all, it's a good protection for your server. Right? You don't want to get huge requests that might crash your server or get you out of memory. But you can do better than setting a hard limit. Right? Think about some API that you have that gets a list of IDs, for example, and returns some information to the client. And you want to be nice so you don't limit the length of the list. But once you get this service gets popular and you have many users, it might be a problem, right? Then you can do a few things. Usually, again, it's the database that gives you the trouble. So you can put the database on a larger machine, or you can do some sharding, or another option that handles it from the database side. But it's good up to a limit, again, and it will cost you money. Another option is to do nothing, but the outcome will be that your server will probably get stuck. It won't serve any request and get crushed, right? Not a good option. But I want to show you a third option. What if you can do this size limiting dynamically? Right? So when the server is not busy, allow for a large set of requests and be nice to your users. Once your server gets busy, start to limit the number of requests from the users and still provide a minimal service to those users. I think it's the nicer or the nicest option without spending having additional costs on servers. And with Spring, you can do that easily. In this case, the filter is not a pre-existing filter of Spring. It's something that I wrote. Basically, you take the content length in this example and checking the configuration for the max size and comparing them and return some error about the payload if it's too large. But the max size can be dynamic. In this example, it's simple. I'm just reducing the maximal size, simulating a growing load on the server. So when I run it, I expect to have, sorry, it's not that. Expect to have some requests that run smoothly, and the others getting an error once the max size is being reduced due to this fake load. Let's see that. So first request is okay, second is okay, third okay, and fourth one is too large. Now if I not only reduce the max size in one direction, also enlarge it, simulating load being removed, then we'll start getting some okay results as well. So you can do it dynamically. And basically, I think that's the main advantage of Spring Cloud Gateway. You can do everything dynamically and give better services. One last thing. I want to tell you about some use case in which Spring Cloud Gateway not only helped us solve the problem, it also saved us money. Right? What was the problem? When you start building an application with lots of services, the developers started to have problems in running the environment on their own machines because they ran out of memory. Right? Running everything locally is good for 5 services, 10 services, depending on the size of your services. But at some point, it's not enough. So again, you have a few options. You can run everything in a cloud environment or on-prem, giving each developer its own full-scale environment, but that will again cost you money because you have to pay for the servers. Sometimes it's a lot of money if you have thousands of developers, right? Or you can run everything in a common environment, but in this case, you have one environment which is good. But in this case, you have in the same environment duplicate services which might be different, right? I'm developer 1 working on service 1, while there is service 1 in an older version running in the common environment, and now developer 2 is making a request to service 1 from service 2 or from a browser, and things might be broken because I've changed the API now, and maybe I'm debugging and halting the other developer. Not sure if you encountered such a problem if you're running in Kubernetes, but we decided to use Spring Cloud Gateway to solve this issue. Anyone heard about telepresence in the Kubernetes environment? Oh, a few. This is the same idea, but we did it a long time before they did it. Basically, what we did is registered the local services, not in the global name service 1, but added it the developer, actually the developer machine name. So in this environment, we had 2 different service 1. One called service 1, and the other one is service 1 with the developer identity. So when another developer made a call to service 1, he got the global service 1, which is interesting. That's what interests him because he's working on service 2. So he gets the valid copy of service 1. But when developer 1, let's say through a browser, made a call, and this call reached service 1, the gateway knew that the request is coming from developer 1 and routed the request not to service 1, the global service, but to service 1 with the developer identity. So basically back to his own machine. That's how we managed to use one common environment, saved a lot of money on different hundreds of environments for the developers with the help of Spring Cloud Gateway. By the way, if you're working with Kubernetes, telepresence is doing something similar, and there are other products like that as well, but Spring Cloud was there first. So let's wrap this up. I hope you use an API gateway. If you're not, I don't know how you manage stuff, but consider using it. don't overkill. If you have a simple, very simple routing case, you can use Nginx, you can use some simple Kubernetes option or whatever you want. But if you need to customize stuff or extend stuff or do one of the many things I've shown you here and give better service, then Spring Cloud Gateway is a great option. So I hope I convinced you that you should at least know and consider Spring Cloud Gateway, and later on, tell me what you think. So thank you for listening, and we'd love your feedback later on.